So in our last class yesterday, we talked about a transformation of a graph of a function. Okay, let me draw a graph of a basic function one more time. Okay, so we have a basic function. We had 7 basic function. So the very basic first basic function is if our function is linear function y equal to x. This is a linear function, and the graph of a linear function is a straight line. Okay, so the graph for this function is a straight line. So this straight line passes through origin, but the other straight line, they may not pass through origin. But whenever you have a linear function, we get a straight line as a graph. Okay, then next we have a y equal to x square function. And what kind of function is this? What is the name of this function? The function is quadratic function or a square function, and the graph for this function is parabola. Okay, so the graph for this square function is always parabola. The next we have y equal to x cube function. This is a cubic function, and the graph of a cubic function is, so this is the shape of the cubic function, graph for a cubic function. Okay, the next function we had y equals to square root of x. We have a square root of x. It means this is a square root function. Okay, and the graph of a square root function is, so the graph for this function is, so this is the graph for a square root function. Okay, every square root function looks like this. The next basic function y is equals to we had cube root of x function, and the graph of this function is, so this is the graph for a cube root function. Okay, so we have 5, so we have 2 more. The next one we have absolute value function. So this is our absolute value function, and the graph of the absolute value function is v shape. Okay, so you draw v. So this is a graph for a absolute value function. And the last one that we had is y equals to 1 over x, which is reciprocal function or rational function. Okay, it's the same thing. And the graph of a rational function or a reciprocal function is, the graph looks like this. Okay, now you have to, like if you just, once you do your homework and just practice more, the graph will be like, it will be on your mind. But in case if you don't know, you can always use your graphing calculator. You can always use your point. Okay, like make a table and plot a graph. Okay, for this function. Does anyone need handout? Okay, so these are 7 basic function, and in this section, with the help of this basic function and different transformation, we will graph a more complex function. Okay, so these are the very basic function, and we're going to use this basic function graph to graph a complex function. And the very first transformation is that, so if we have a function, okay, so let's say we have a function and we are adding a number, let's say c be any number, and if you add any number to a function, then our graph of that function is shifted vertically up. Okay, the graph is shifted upward by c units. Like for example, so here, so this is our basic function. Okay, in this basic function we added 4, and whenever we add a number, positive number, to a function, then the graph is shifted up. Now this graph is shifted up by 4 units. Okay, so every time if we are adding a number to a function, then the graph of the function is shifted vertically up. Okay, if we subtract a number, now let's say we have a function and you subtract a number from the function. In this case, the graph of the function is shifted downward by c units. Okay, now if, so here we have this graph for a basic function. Okay, and in this basic function we subtracted 2. So here we subtracted 2, and whenever we subtract 2 from a function, then the graph is shifted down by 2 units. Now this graph So this is the basic graph. Okay, we subtracted 2, then the graph is shifted down by 2 units. So when you subtract a number from a function, the graph is shifted down by 2 units. Okay, so this is the one. The next here, so we have a function, and if we replace x of a function by x minus some number, okay, like x minus 4, x minus 3, x minus 1. You have a function and for every x in your function, if you replace x by x minus some number, then the graph is shifted on the, where the graph is shifted, if we replace x by x minus c, it is shifted right by c units. Okay, so here, so this is the graph for a basic function. Okay, and now we subtract it to, then we replace x of this function. So this is the x, and we replace this x of a function by x minus some number, x minus 2. And when we have this replacement, our graph is shifted on the right by 2 units. Now this is the final graph for absolute value of x minus 2. Okay. Similarly, if you replace x of a function by x plus some number, c is any real number, then the graph is shifted on the left by c units. So here the same basic graph is shifted on the left by 3 units when we replace x of a function by x plus 3. Okay, you add a number to a function, it goes up. You subtract a number to a function, it goes down. You replace x by x minus some number, it goes right. You replace x by x plus some number, it goes left. Okay, so these are the transformation that we talked yesterday. Now the next here, so we have a function here, okay, f function. Now if we multiply our function by a number which is greater than 1, so we have a function, okay, now we multiply of that function by a number which is greater than 1. In that case, our graph is traced vertically away from the x-axis. Okay, now here, so we have our function. So this is the basic function, graph for a basic function. Okay, this red one. And when this function is multiplied by a number which is greater than 1, so we have this c of f of x. We multiplied a function by a number which is greater than 1. In this case, the graph, the basic function graph, so this is the basic function graph. Okay, this graph is traced vertically away from x-axis. So this is our x-axis. Okay, now the graph is traced vertically away from x-axis. It means this is the graph when we multiply our function by a number which is greater than 1. So you have a function, you multiply your function by a number greater than 1, then the graph is traced vertically upward, okay, away from the x-axis. Now instead of a number greater than 1, if you multiply by a number which is greater than 0 and less than 1, so you multiply a function by a number in between 0 and 1, then in that case your graph is compressed vertically towards the x-axis. Okay, so when you multiply by a number in between 0 and 1, this is the final graph. It means it is compressed vertically towards the x-axis. If we multiply a function by a number greater than 0 and less than 1, okay, if you choose to multiply by a number greater than 1, it is traced vertically away from x-axis. Okay, if you multiply a function by a number in between 0 and 1, then it is compressed vertically towards the x-axis. It goes towards the x-axis if a number is in between 0 and 1, and it goes away from the x-axis if a number is greater than 1. Okay, so this is the next transformation. Okay, so let's do one more transformation, then we'll do an example. So here we have a function, and you multiply a function by a negative. Okay, so you have a basic function, and if you multiply your function by a negative, then there is a reflection across x-axis. So this is a graph for our function f of x. Okay, now we multiply this f of x by negative. Then whenever we multiply a function by negative, then there occurs a reflection across x-axis. Okay, so reflection means you can just imagine that you have a mirror along the x-axis. Okay, so if we have a mirror along the x-axis, and this is the function that we have here, so this is the graph that we have here. When we place a mirror here, and this is the image that we're gonna see, right? So this is the reflection. So whenever we multiply a function by a negative, it is reflected across x-axis. Okay, now with this transformation, let's try to plot a graph here for different function. Okay, so in number A, so it does tell us to identify our basic function. Okay, so very first thing is that we need to identify the basic function, then use transformation to sketch the graph of both of this function. Okay, so for this function, what kind of function is this? What is the name of this function? So we have g of x equals to 3 times square root of x. It is a square root function, right? So if this is a square root function, what will be a basic function here? What is the basic function for a square root function? Basic function is, so your basic function will be the function from this, the 7, okay, out of this 7. So you will be doing functions similar to this 7 basic function. Okay, so our basic function would be f of x equals to square root of x. So this is our basic function for a square root function. So our basic function is f. Okay, it tells us to write down f of x. So our basic function f of x is square root of x. Can you all identify the basic function? If you know the type of a function, then you should be able to find the basic function. Okay, so this is the square root function. So this is our basic function. Now let's make a graph for this basic function. So the graph of basic function, it does not need to be exactly same. Okay, if you have a close enough graph, then you should be good. So this is the basic function for the square root function, and the graph is this one. Okay, now so our target is graphing this g of x. Now what do we need to do, okay, for our basic function to get our g of x? How can we get g of x from this basic function? You are allowed to add, subtract, multiply, replace, division or divide. Yes, what do we need to do? So if we compare here, we need a 3 in front of square root of x, right? And in order to get that, we need to multiply. So we choose a number 3 which is greater than 1 to multiply. Now what happens to the graph? So whenever we multiply a function by a number which is greater than 1, we choose 3. 3 is greater than 1. So what will happen to our graph? Now let's go back to the notes. Okay, so here, so here, if we choose a number to multiply, number greater than 1 to multiply a function, then the graph is stretched vertically away from the x-axis. Okay, now how do we draw that here? So what will be your final graph? So we have to multiply here basic function by 3. Okay, so multiply by 3, and whenever we multiply by 3, the graph is stretched vertically away from the x-axis. Now what would be the graph here? So how can we stretch this? So we have to stretch this graph vertically away from the x-axis. Okay, so this is our x-axis. So this is our x-axis, and we need to stretch this graph away from this x-axis. Okay, we need to stretch away from x-axis. What would be the final graph look like? Okay, do you all agree stretching away means this is, do you all agree with this graph? So you are stretching away from the x-axis. If you are multiplying by a number greater than 1, then you're going to stretch your graph vertically away from the x-axis. Okay, so this is our final graph for g of x. So this is our g of x, and this is our f of x. Bless you. Okay, does anyone have question for number A? Now let's go to number B. So in number B, our g of x equals negative 2 times absolute value of x. Now at first, what kind of function is this? What is the name of this function? Absolute value function. Okay, if it is the absolute value function, what will be a basic function for this? So basic function is function f of x would be absolute value of x. So this is our basic function. So let's make a graph for this absolute value function. So the graph for this absolute value function. So this is the graph for the absolute value function. Now we need to get g of x from our basic function absolute value of x. Now what do we need to do? How can we get this negative 2 times absolute value of x from this absolute value of x? Okay, multiply by negative 2. Now when we multiply by negative 2, what happens to the graph? So we have the negative in the front, and whenever you have negative in front of the function, there is a reflection across x-axis. Okay, now for this graph, what would be the graph if you place a mirror over this x-axis? So the graph looks like exactly same, right? It is reflected across x-axis. Okay, so this is reflection across x-axis. Now this is the graph for negative absolute value of x. So let me call it h of x. But we need a 2 in front of negative absolute value of x. Now how can we get 2? So here, now if you have a confusion, you can always use a table. You can always use the table. Okay, now we can just make a table here and draw a final graph also. Like, so here our function is g of x is equals to negative 2 absolute value of x. Now let's make a table. So we have a x, we have a output g of x. So we can choose any number. If let's choose x equals to 0. If x is equals to 0, what will be our g of x? Is it negative 2 or 0? So we have negative 2 times absolute value of 0, that is 0, right? Okay, let's choose 1. Then we have negative 2. Let's choose negative 1. Do we get, okay, still negative 2, right? So if we choose positive 2, if our x is positive 2, then we have negative 2 times positive 2, negative 4. And we have negative 2 for x, then our output is it still negative 4? Negative 4. Okay, now you can plot these points and get the final graph. Okay, so we have 0 0, so we have 0 0 here, 1 and negative 2, so we have 1 negative 2, so this is 1, so this is negative 2, right? Then we have negative 1 negative 2, negative 1 negative 2, then 2 negative 4, so we have 2 negative 4 and negative 2 negative 4. So if you connect all these points, we get a final graph. So it is straight vertical away from the x-axis. Okay. So when you have the negative, you reflect across the x-axis. Okay, if you multiply a function by a number greater than 1, then you are stretching away vertically away from the x-axis. Okay, now the next here, number C, we have a function g of x. Now what kind of function is this? What kind of function is this? Absolute value function, right? So our basic function is, so let's start from a basic function. We always start from a basic function. So our basic function is y equal to absolute value of x. Now let's draw a graph for this basic function. So our basic function, the graph for a basic function is this, the graph for a basic function. Now from this basic function, we need to get negative 2 times x plus 1 plus 3. Now how can we get? So what do we need to do here? So this is what we have, okay? We only have absolute value of x. And from this absolute value of x, we have to make this absolute value of x equals to negative 2 times x plus 1 plus 3. And we are allowed to add a number, we are allowed to subtract a number, replace, multiply by negative or positive number. So what do we need to do here? So what would be the first things that we need to do? And we need to do step by step, okay? So if you are adding, then you are adding a number first, because that changes the graph. Then if you are replacing, then you can replace. Now here, so what differences do we find? Now if we compare, let's make a comparison here. If we compare these two functions, so for our x, what do we have? We have x plus 1, right? So for x, we have x plus 1. And how can we get this one? By adding, subtracting, multiplying, or replacing. So we replace x by x plus 1. That's the one thing that we need to do. And we have a plus 3 here. 3 has been added here. It means our 3 is missing here. And in order to get that positive 3, we have to add 3, right? So adding 3 means we are moving our graph vertically up by 3 units. We have negative 2 in front here. It means we have to multiply this function by negative 2. It means there will be a reflection across x-axis. Yes.
Does it matter which one we do first?
Now we can try. Okay, now let's see. So what transformation do we want to try here? Do you want to start by adding 3 or like multiplying by 2 or replacing? It will make a difference, okay? Bless you. Now let's see what happens if we add 3 at first, okay? Now for this basic function, so we have a basic function, absolute value of x, and let's add 3 first. So adding 3 means our graph goes up by 3 units, right? Do you agree with this one? Okay, so we have this basic function, y equal to absolute value of x, and we added 3. Adding 3 means our graph goes up by 3 units. Now next, what do you want to do? So we want x plus 1 instead of x, right? So let's replace x by x plus 1. So we have absolute value of x plus 1 plus 3. We replace x by x plus 1. And what happens to the graph? It goes left by 1 unit, right? Now, what we need, we still need negative 2 in front of absolute value of x plus 1. And for that, what do we have to do? How can we get negative 2 in front of absolute value of x plus 1? By multiplying, right? So let's see, let's multiply this function by negative 2. Now here we have a more than one terms. Multiplying means you can't simply multiply first term, you have to multiply both number here. So let's multiply by negative 2. So we have negative 2 absolute value of x plus 1 plus negative 2 times positive 3 is negative 6. Now do we get our g of x function? So it's not the same. We have a negative 6 here. We were supposed to have positive 3. So here it's not helping us. So order, it does matter. So what we can do is that, so every time, so you multiply the function at first. Okay, like when you start from a basic function, you multiply first, okay? Then you can add or replace. It doesn't matter. Like you can just add in the second and you can just replace third, okay? Or you can just replace in second and add in number third, okay? But if there is a, if a number has been multiplied to a function, then that's the very first thing you have to do, okay? Now here, so So like whatever we did here is not the correct here. It does not give us the final answer. So let's start by multiplying this basic function by -2. And the reason is that we need -2 in front of absolute value. So we need -2 in front of absolute value, right? So let's multiply this function by -2. So multiply by -2. So we multiply by -2. And when we multiply by -2, what happens to our graph? It is reflected across x-axis and is traced vertically away from the x-axis. So you reflect across x-axis. So this is the graph here. Okay. So let me just write down the transformation here as well. So when we multiply by a negative number, reflected across x-axis and is traced vertically. Away from x-axis. Okay, so this is the transformation. Whenever you multiply by a negative number, you have to reflect across x-axis and trace vertically away from x-axis. Okay, now after multiplying our basic function, we have a function y equals to -2 times absolute value of x. Do you all let me know if you have any question up to here. So what we did, we multiplied a function by a -2, and because of that our graph is reflected and is traced vertically. Now the next, what do we need? So we want x plus 1 instead of x, right? So instead of this x, we want x plus 1. And how can we get that? We replace. So we replace x of a function by x plus 1. And replacing x by x plus 1 means our graph is shifted on the left by how many unit? By 1 unit. Now let's shift this graph on the left by 1 unit. So this is -1. So we shift this graph on the left by 1 unit. So when you replace x of a function by x plus 1, then your graph is shifted on the left by 1 unit. And so the function becomes, our function y becomes -2. We replace x by x plus 1. So absolute value of x plus 1. Now next, what we need? We need plus 3, right? It means we add 3. So let's add 3. So we add 3. So adding 3 means we are moving our graph vertically up by 3 units. Okay. And so we have y equals to -2 times absolute value of x plus 1 plus 3. So this is our final function. And we have to shift this graph vertically up by 3 units. So our final graph is red. Now we are shifting this red graph vertically up by 3 units. So this is 1, 2, 3. So this is -1. So this point, okay, let me use a different color here. Okay, our final graph is, so this is the final graph for our g of x function. And you can always double check by plotting a point or by using your graphing calculator. Okay, and if you have a graph close enough, you get the full credit. You don't need to have like exactly accurate graph. Okay, you just need to have close enough. Okay, so we started from this graph. So we started from this blue graph, right? Then we reflected and traced vertically. Then we move to the left and we move up by 3 units. And this black graph is the graph for our function g of x. So if we know the transformation, it will be easy to graph a function. Okay. Okay, does anyone have question? A, B, C. Okay, we have one more. Okay, we have 2 more transformation. Okay, so the next is now here we have a function, and now if you replace a function, if you replace the x of a function by c times x, okay, and your c has to be greater than 1. So you have a function and you replace x of a function by some number times x, and the c has to be greater than 1. Like for example 2x, 3x, 4x, or like 4.5x. Okay, if you replace x of a function by cx, c has to be greater than 1, then the graph is compressed horizontally towards the y-axis. The graph is compressed horizontally towards the y-axis. Like here in the graph we can see, so we have the basic function. So this is our graph for a basic function. Okay, so this is a graph for a basic function. Now when we replace this x of a function by cx, and c is greater than 1, then the graph is this one. The graph is compressed towards the y-axis. It is compressed towards the y-axis. Okay, the next, you have a function and you replace x of a function by c times x, and your c is in between 0 and 1. So for example, you replace x by 1/2 x, like similarly 3/4 x. In that case, your function is stretched, or your graph is stretched horizontally away from the x-axis. Okay, so here, so this is our basic function, and when you replace x of a function by cx, your c is in between 0 and 1. The graph is stretched horizontally away from the y-axis. If you replace x of a function by c times x, your c is greater than 1, then it is compressed horizontally towards the y-axis. Okay, if you replace x by c times x and your c is in between 0 and 1, then your graph is stretched horizontally away from the y-axis. And the last transformation is, if you replace x of a function by negative x, you have a function, you replace x by negative x, then the graph is reflected across y-axis. Okay, so this is the graph for our basic function. Okay, now reflection across y-axis means, now if we have mirror along the y-axis, then this is the image that we're gonna see. Okay, so whenever you replace x by negative x, there is a reflection across y-axis. These are the transformation. Okay, now here I want you to, so if you know every transformation, that's perfect. Okay, but at least I want you to know. Okay, so let me just make a list that you need to know, at least the very basic. Okay, the very first is, let's start from y equal to f of x. This is our basic function. So I want you to know what happens when you add a number to this function. So what happens to a graph when we add a number? It goes up, right? So I want you to know this one. Now what happens to a graph if you subtract a number from a function? What happens to a graph? It goes down. Okay, now if you replace x of a function by x minus c, you have a function excuse me, you replace x by x minus c, what happens to the graph? It goes right by this c unit. Okay, similarly it goes down by c unit, it goes up by c unit, like whatever number you are using. If you replace excuse me, x by x plus c, what happens to the graph? It goes left. Okay, and two more. So if you multiply your function by negative, you have a function, you have a negative in front, what happens to the graph? It is reflected across x-axis. And the last one, if you replace x by negative x, instead of this x you have negative x, then it is reflected across y-axis. So reflected across x-axis means you just imagine you have a mirror along the x-axis, okay? And reflected across y-axis means just imagine you have a mirror along the y-axis and you find the image. So I want you to know at least this transformation, okay? And if you have this, you should be able to do your homework, quiz, or like even exam, okay? Okay, has anyone carried book by any chance? Okay, can I borrow your book? Okay. Let's practice some of the examples from our homework. Okay, these circles should be the homework. Okay, now here, okay, let me start from number 31. Okay, this is the one that we didn't do, so let me start number 31. This is your homework. Okay, so in 31 we have a graph here. Okay, the graph is, so this is -1, this is +1. So this is the graph given to us, and it tells us how the graph is transformed from the basic function and find the suitable expression for the function represented by the graph. Now for this graph we need to write a function. So every examples that we did earlier is that we were given a function and we draw a graph. Okay, now here we are given a graph and we need to write a function, okay, closed function. It may not be exactly same function, but we want to have a function whose graph is similar to this graph. Okay, now at first, from this graph, what can you say about the function? What would be the type of function for this graph? Absolute value. So the basic function is y equal to absolute value of x. Okay, now we know the graph of absolute value, we know the graph for this basic function, right? So one more time, the graph is, this is the graph for the basic function. Now what difference do we have in between these two graphs? The graph, so this is the graph for the basic function. If we compare to this graph has been shifted on the left by 1 unit, right? Now what does it mean by shifting left by 1 unit? What do we have to do? We have to replace x of a function by x plus 1. So instead of this x, you write an y equal to absolute value x plus 1, and this is the function. Okay, absolute value of x plus 1 is the function for this graph. Okay, let me do similar one more. Okay, so let me do number 38. 37 is your homework. So we have a graph here. So this is -2, this is +1. Okay, now this is the graph we have, and we want to write a function for this graph. Now from this graph, what can you say about the type of function? What type of function we're going to have here? Square root or a square? Square. Okay, so our basic function is y equal to x square, so we're going to start from here, and the graph for this function is, this is the graph for the basic function. Now we compare these two graphs. Now what do we need to do to our basic graph to get number 38 graph here? What differences see here? So we have this graph here. Now what do you see? What kind of transformation do you see here? The graph has been shifted up, right? The graph has been shifted left. Okay, now how can we, so let's take, the graph has been shifted left by 2 units because the graph was here, the basic graph is here. Okay, now this graph has been shifted left by 2 units, and how do we write down that? What do we need to do to shift on the left by 2 units? Are we adding, subtracting, or replacing? We are replacing. Okay, so we replace this x of a function by x plus 2. So we have y equal to x plus 2. We have this square more than 2 terms, so parenthesis. Now after that the graph has been shifted up by 1 unit. How do we get that? How do we shift a graph up by one unit? What do we have to do? We have to add 1 to our function, and this is the final function for the graph number 38. Okay, and you might have, let me see. Oh yes, you do have. So one more problem that we didn't cover here. Let me do from your homework. Okay, can you just write down the function from the graph? And the next very common problem that you're going to have on your exam is you will be given a statement, okay, with a different transformation, and you have to write a function, final function here. So like in number 39, just let me read. So in number 39, the graph of a function g of t is formed by translating the graph of ft. So we have a graph of a function g of t, okay, and this graph is formed by translating the graph f of t. So we have f of t equals to absolute value of t. Okay, this is absolute value. So we need to form this, we need to make this, find this g of t, okay, and what is given to us is that this g of t is formed by translating this f of t, okay, to the left 4 units. Now to the left 4 units means what do we have to do to the basic function? Replace t by, to the left, t plus 4. Okay, so our f of t becomes absolute value of t plus 4, and the next and down 3 units, minus 3. So down 3 means minus 3, and this is our g of t. Okay, let me do one more. Okay, let me do number 41. So we need to write the equation of a function, okay, and your function is starting from f of t equals to t squared. The basic function is this one, okay, and the function is formed by a factor of -3. Now how do we write that? Factor of -3 means we are multiplying this basic function by -3, so we have -3t square, and moving it to the right by 1 unit. What does that mean? Moving right by 1 unit. Are we adding or replacing? It's replacing t by t minus 1 or t plus 1? Minus 1. So we have -3 t minus 1. So you just replace t by t minus 1, and everything remains same, 2. And this is our final g of t. So from this section, you can have a 3 type of problem. One is you will be given a function and you will be asked to graph a function using transformation. Okay. Second problem is you will be given a graph and will be asked to write down a function for that graph. Okay. And the last one is similar to this 41. You will be given a words, okay, statement. You will be given a transformation, and from that transformation you have to write down the function for a given. Okay, I said this is all for this section, so let's do this much for today. If you have any question, I'll be here for like 4 more minutes, and if not, I'll see you tomorrow.